他是戴耳机哦。哎 ，Brandon， 你叫嘉义一下。
So you see, our class so
怎么
supportive.
这该讲话？
所以你要给 tips 啊。
I got total 80 students 啦，因为我们占了50%。
哦 ，only us 啊？哎呀。
哦 you mean your group?
You give us tips then this is
So, so what you want?
我忘记了。
Just maybe.
耶，我去唱出。
我有唱歌。是给唱歌出啊？
他们以前会是像那样的。
But not today lah, of course. Anything arrange in our class.
我那睡才给。
I feel like I'm eating.
耶！看我们几场。
哦，shit！
嗨。
痛死了。没有钱吗？
可以开吗
看下试下。可以。
？OK， 好。
哦，好彩 ！Oh my
只要
god！
开了之后，它却没有问题啊。
圣杰，Samsung Z。
哎，不讲 new 生 new you 吗？
就在跟。Come on, we change class ah, since this class.
Let's go。
而且我做成 L 哎，做怂。
No, we don't have to. I don't know. I mean, I have to apply. Okay lah.
We go rampas lah.
Yeah, 世界君看住。I'm sorry。
Your report 170 pages.
Huh?
170 meh? I thought 140 something. 170. Maybe got add on lah. Maybe they add
真
on
不好
something.
说啊，那个球员。
哈？
You want your group also 100 pages.
你笑啊？
就这样多，100多面。
回来。
你们的 report 这么多。
Assignment. Assignment documentation.
哦，patient。
This 170. It's even thicker than my thesis.
哦，耶稣是哪？我以为是那个 check 那个字的那个。
嗯，耶稣。
可以接受哦。不是，我以为是那个。
就后来加书。
看来是就。
有100%。
我是死人班 origin. 我在 KL
靠近了，靠
超过3
近了，一样。
年。我在 KL 已经超过3
Because
年
we
了。
put many output.
加书啊。
We put output for you.
没有这样读。
死人班的特征是给我。
labels and the description.
看得出。
I see a lot of output, a lot of pictures, but you didn't describe, you didn't like really analyze. Like it become those you should put at the appendix.
You just put anything.
Yeah, especially you throw, wow, a lot inside, a lot of
之
content.
前有 data， 数据还有。
Sorry 啊。
Okay.
你上面 OK 吗？
是。那个 data 会用完吗？应该
I
会
just
不
wonder how much time that you put to
So as you can see, you put so much effort, right?
哇，me too。
what is the hidden meaning?
increase 吗？耶！
睁一只眼闭一只眼。
是他生气了。你看，你这样这样。
Where's your teammate? What's the name?
啊？
Yin, you what?
阿燕，很多燕啊。
修燕，那个岛。
lick dog。
Let's say presentation, teaching training. You forgot everything.
那个燕。
Just forgot everything.
You can call her lick dog。
那个岛。new name。
L 你们。
圣杰谁嘛？
哎，没有啊，我讲过。
善良大甜口。
圣杰 how you like that？
他是个绝情的。
太流了，你可以做2份资料。
没看到那时候吗？
不是全部都做。
对。
突然觉世界。
他在跟他笑。
这是一个伤心的人。
他在恶心。
你们懂自己坐旁边没有？你们懂自己坐旁边吗？那你问你懂子晴哥什么？子晴坐在旁边讲的大声。是？子晴坐在以梦旁边，他讲的大声。
听不到，听不到。风向啊，direction。
几番讲了，不这样的。
就这样。Oh, your marks affect my marks. My marks will not affect your marks.
OK。会讲话就像安迪啊。算了啦，你们什么中毒啊？
宝贝呀。
不然你看我们的3D没有看到你就发现新世界。
又来一个。
耶，有菌看出。懒觉啊，怎么 check 不到啊？
累
没有，不是累，只是有问题，JavaScript 的问题啊。
Okay, good afternoon all. So I'm teaching group 1, is it?
Yeah.
I think majority is from SEM 2 group 1.
Yeah.
Today will be our last class,
Ah.
last chapter for this course. Congratulations.
Yeah.
Time passed very fast for week 13. Then you're almost end of the semester, so you don't need to record anymore.
No.
We want to.
Next week we still have a lecture class, but I will mainly discuss the faster questions and maybe go through the overview of what is the
Guidelines.
Guidelines.
No tips. We don't need tips.
You don't need tips,
Guidelines.
Let's see. If I good mood, then I will see how. And if I remember, because I set the questions back to many weeks ago. See whether I got time to revise or not. Okay. So today's we will cover the last chapter. So you have another chapter, which is chapter 14, modeling and simulations, which is not covered in our syllabus lah. So we need to study that chapters. We will cover this. This is the last chapters, and we have a 2-hour lecture class. This first hour I will cover of fuzzy logic, and then after that I will cover the tutorial for this fuzzy logic. Means that we next week we will cover the tutorial 12, right? So today's I will cover the tutorial 13 as well lah. Right. Okay, so what is fuzzy logic? Jackson, don't know. Anyone, have you even see these words in like washing machines or aircon, rice cooker? Yes, sir. If you are so-called you will check your house appliance like the washing machines, rice cookers, you probably have seen these fuzzy logic words on it on the washing machines. Okay, so what is fuzzy logic? Fuzzy logic is basically mathematical logics to handle the uncertainties. Okay, so what is a fuzzy logic? So it's just a mathematical logic to handle reasoning okay, so it's basically just a mathematical logic to handle the reasonings with the ambiguities, imprecise and uncertainties. If you still remember last week we covered chapter 12. Anyone still remember chapter 12 what we have to actually cover?
So
Did you attend? Yes. Remember? Okay, yeah. So we have actually covered two things. It's a probability, probability, which is Bayesian theorem, and another one is known as certainty factors. So what is this? Probability and certainty factors. Yes, Brendan. So these two are actually a technique to handle uncertainties.
My God.
Thank you. So I guess I'm responding. So what is uncertainties? Yes? I heard something. Jackson again.
Unable to predict.
Unable to predict. Thank you for your good try, but it's not prediction. So expert system is not. It's not relevant to anything to a prediction or so-called machine learnings. Okay, what is my question? What is uncertainties? What is it? Reliable conclusions.
Based on true or false.
Okay. So, uncertainty. You may say that uncertainty is a word that is ambiguous, that is not very clear, that is not complete. For example, not sure. For example, probably. Okay. For example, perhaps. Okay. For example, I'm quite sure. Okay. So you say you're quite sure. How sure you are? How sure you are? You don't know. I'm partially. So how full you are? So are you hungry? So I'm partially hungry. I'm not really hungry. So you have this kind of not really uncertain, partially. So this refers to uncertainties. So whenever you have uncertainties, then you have to either use this kind of techniques, probability, which is the Bayesian theorem, certainty factors, or fuzzy logic to handle, right? To handle the reasoning that which come with the uncertainty. So what is the reasoning? If you still remember, you have to back to the chapter 11, which is the expert system. Okay, so we use the so-called observation map together with your rules, right, and then come up with the reasoning. So fuzzy logic, yeah. So this is just a theory. It's just a set of mathematical principles based on degree of membership. So Boolean logic use sharp distinctions. So we have basically two types of logic, two types of rules. The first one is called Boolean logic, which is where you have to set a threshold value, or if you have this value, if your blood pressure is more than 110, let's say, then you so-called you having this hyperpressure. So if you are less than this value, then you do not have this hyperpressure. So we set a threshold value and to classify whether you are in this class or in another class. So you're either in A or either in B. Okay. So meanwhile, the fuzzy, which where we have a value in between, right? It's not only yes or no, but we have a value in between yes or no. So I will take an example for the Tor. Okay, so to compare with what is so-called the Boolean logic and what is so-called the fuzzy logic. So assuming that I would like to collect the data to measure your height, whether you are tall or you are not tall. Okay, so I have 2, 4, 6, 8, 10. I have 10 students here. Okay, so by using a clip logic, which is a binary or Boolean logic, I have to set a threshold. Let's say, if your height is more than 100, then I will classify you as tall. Okay, if you are less than, then you're considered not tall. Not short, is not tall. Why so hot?
So you are hot dog.
Okay, so we look at the crease. Crease is 192 cm. So then we just check at this rule. So this is actually a creep rule. If the height is more than 180, then we have to classify as tall. So if you look at the second data, which is mark is 189 cm. So it's more than 180. So we classify them as classify Mark as tall. So John is 185, so we set a threshold. So it's as long as it's more than 180, then he is or she considered tall. How about David? David is 175. He's 175 cm, so whether is it tall or not tall? Not tall. Is it? It's based on the Crick rule. But is it fair to the David? Do you think 175 is tall? Yes, right? Anyone?
Tall enough.
In Asian country, 175 is considered tall, right? So how tall are you? 180, yeah? I think you are 180. So I'm quite short, so I'm 173, 72? Don't know, not sure. Okay, so this is not fair to the David, which is 175. It's somehow tall, but if you use the Crick logic, it's considered not tall. So not all the measurements, which is the height in the real life, can be categorized in either yes or no. So we should have some techniques to measure whether David is somehow tall, is quite tall, instead of just set a threshold and to put the David in either tall or not tall. So this is not fair to David. So throughout this 1 hour, you're going to learn what is the most common fuzzy logic inference mechanism. It's called Mandami. Okay, so this is one of the very famous fuzzy logic inference mechanism. You have another type of mechanism. It's called Sugino. So, but today we are not going to cover this. We'll just cover the Mandami. We will see the overall architecture on how Mandami fuzzy logic inference system works. What are the components that is inside the Mandami inference mechanism? Okay. Okay, so to understand the architecture for Mandami mechanisms, you should understand several components, which is fuzzy set, fuzzy rule, and the defuzzifications. Okay, so I'm going to teach you how to set or come up with a fuzzy set. I'm going to show you how to define the rules as well as how to convert the fuzzy logic back to numerical values. Okay, so yeah, so this is another example. If let's say you have a 0 degrees Celsius, so we can just set a threshold value. Anything that below 20 degrees Celsius, it belongs to cold. Anything above 20 degrees Celsius is belong to not cold. So this is not really appropriate. We should have some, let's say 0 is not quite cold. 5 is on the side, on the cool side. Yeah, a bit cold, barely cold, not cold. We should have this kind of uncertainties. Okay, so this is the common applications. You probably see the washing machine. You have a fuzzy logic icon there. Some rice cooker, you come with this technology also, fuzzy logic. Okay, you realize it? No, go back to I'm going to check your washing machine, your rice cooker, aircon. Sometimes aircon come with that fuzzy logic. Okay, so the icon below here. So this graph here, this is actually a Mandami fuzzy logic inference mechanism. Okay, so to calculate the so-called the gray levels or the middle bound between the value here, so you have to go through this process, falsifications and defalsification. So before we go through these two processes, before I explain in further what is these two processes, you have to understand first what is fuzzy set, what is fuzzy loop, and defalsifications. Okay, come back to this graph first. Okay, so how do we come up with this value? Degree of membership. Okay, so you can think that this Chris, Mark, John, Tom, David, Mike are the elements. Okay, so assuming that we would like to measure how tall. Okay, so tall, short, these are actually classes. Okay, so they actually belong to height. It's called measurements. Okay, so what is degree of membership is where to what extent you agree. How many of you agree? Okay, let's say Chris 192 cm. How many of you agree that Chris should belong to tall class? All of you agree. Then I give a value 1.0. Okay, let's see maybe Tom. Tom is 181 cm. how many of you agree that Tom is actually belong to tall class? Maybe majority. Maybe some of you feel that 182 is not really tall. So some of you disagree, but majority agree. So we should have a value called 0.82. Okay, and then we have a value of 0.82. Okay, Bob. Bob is 164 cm. So how many of you agree that Bob is actually belong to tall class? Maybe half of you. Yeah, in Asian country, maybe half of you are not really agree. Then we have this value 0.64. Okay, you can assume that degree of membership is kind of to how many of you really agree that this element is belong to this class. Okay, is that clear until this stage? Okay, so I'm going to show you these examples to show you how a Mandame inference mechanism works. So a washing machine, you would like to develop a fuzzy logic washing machine. So this washing machine can load up to 9 kg cloth. Minimum 0.1 cloth to perform its washing task. So you have 3 options to weight the cloth, right? You have low, medium, and high. So you have to create fuzzy set to demonstrate the spectrum degrees of heaviness, a membership functions, and a graph to represent the membership functions. Okay, so what is the difference between the fuzzy logic washing machine and also the traditional washing machines? Okay, so traditional washing machine is where you throw all the clothes, no matter one piece or 2 piece. Okay, so you throw, you turn on the sheet. You turn on the sheet, you turn on. So when the moment that you turn on, then all the parameters such as the spinning speed, the spinning time, the amount of water are all preset. Okay, so you have a washing machine here. Okay, so you throw the cloth here inside. So the moment you click on button, then the so-called the spinning speed, the amount of water, let's say washing time, are all preset. For example, spinning speed 10 RPM, amount of water 10 liter, washing time 45 minutes. Okay, no matter you throw 1 piece or 2 piece or 1 bunch of clothes inside, the traditional washing machine will just use all the preset parameters to wash the clothes. Okay, so it's kind of a waste of energy and amount of water. So you have only 1 piece of clothes, but you still need 10 liters of water. A kind of a waste of so-called energy, electricity, and also water to wash the clothes. Right. Okay. So that's why we are going to improve this washing machine using fuzzy logic. Okay. So this fuzzy logic will try to find the optimal parameters to wash the cloth. It will base on the number of cloths and to set the amount of water, the spinning time, spinning speed to wash the clothes, to find the optimal parameters instead of just everything preset. Okay. All right. So in the questions, it stated that you have 3 different options. So you would like to design a washing machine. Okay, so it will based on the weight. So weight is your measurement. So you have 3 different classes: low, medium, and high. So you have low, medium, and high. Okay, so this is your input. Okay, it means that you have to base on this input to control the output. So let's say the output here, I will set amount of water. Okay, so I will create 3 different classes under this measurement also. Let's say low, medium, high. Okay, so you have to be clear first what is your input and what is your output. Okay, so input is the weight, how heavy is your cloth, right? How heavy is your cloth? Is it low, medium, or high? And we would like to use this input to control the amount of water to wash the particular clothes. Is it you would like to use a low amount of water, medium amount of water, or high amount of water? Okay, so this is the first step. You have to set the input and output first. Okay, so it already stated load up to 9 kg. So after that, you have to find, okay, then you have to build the degree of membership for each of the classes here. Okay, so how to build the fuzzy set? Just like the measurement of the tall in the previous case. So we have, let's say, the weight, kg. Okay, so we start from 0.1. Let's say you have a 2, 3, 4, 5, 6, 7, 8, 9. So this is the measurement. It means that you put the cloth inside the washing machine. So inside the washing machine there is a sensor. So this sensor will measure the weight of the cloth. Okay, to measure the heaviness. Then after that you have 3 different classes: low, medium, high. Okay, so after that you have to ask yourself, if the cloth is only 0.1 kg, how many of you agree that it belongs to low class? Do you agree? The value is between 0 to 1, degree of membership between 0 to 1. 1 is majority agree, all of you agree. 0 means none of you agree. Okay, do you agree that 0.1 kg belong to low class? Yes, maybe all of you agree. So you still have a value 1 here. Then you repeat. Okay, you have a value 2 kg of cloth. Do you think that it should belong to low class? It still belong to low class? Maybe somehow 2 kg is not really low, right? It's somehow low. So you should have some value, let's say 0.6, reduce. Okay, 3 maybe you have 0.2, and let's say 0. Okay, so this is degree of membership. Okay, you have 0.1 kg. To what extent you agree that 0.1 should belong to medium class? You know, disagree, right? You disagree. So how about 2 kg? Maybe you disagree. Maybe 3, you somehow, you feel that this 3 is still can belong to medium. Maybe you have a 0.1. So 4, maybe you start to have a value of, let's say 0.5. Okay, so you have this one, you have a 0.3, let's say. This is 0.1 and then 0. Okay, last one, you have a high class. Do you think the 0.1 should belong to high class? No, right? So you have a value 0, let's say 0. So you also have start a value here. This is 0.1, let's say 0.4. Okay, so you build this table first. Okay, you have to come up with this table. Okay, if you have a 0.1 kg, to what extent you agree that it belongs to low class, medium class, and high class? Because you have 3 different classes. Okay, so having this information here, we can build a graph called membership graph. So the y-axis is degree of membership. So the x-axis is your measurement, it's called weight, kg. Okay, then let's say I will break into a difference, let's say 9, 4, 5, 7, 8. Okay. Then you start to plot the graph using the information inside this table. Okay, so 0.1, so you have 1 here. Okay, let's say this is 0.1. You have a 0.1, let's say this is 0.5. You have 1 here. So then 2, you have 0.6. Okay, 3 is 0.2. Something like this. Okay, and then plot another graph. Degree of membership against the medium class, 0, 0. Okay, so you have a 0, 0 here. Okay, 3 is a 0.1. Okay, you also have this value. Okay, and then last one is high class. Okay, so let's say you have a 0, 0, 0, 0, 0, then you have a 0.1. Okay, you should have 3 different graph onto this degree of membership graph, so you can join all the lines. Okay, so that is the membership graph based on this table. Okay, so this red color is belong to medium. So this first graph here belong to low, and the black color is belong to high. Okay, so this is the membership graph. So how to generate membership graph is come back with this table. So how to come up with this table? You have to ask whether this 0.1 is it belong to low, medium, or high. The value should bound between 0 to 1. Okay, is that clear at this stage? So you should come up with this. This is so-called fuzzy set. This is actually called fuzzy sets. Yeah. So once you have the graph here, you can generate a membership functions. So how to get a membership function? So this is actually a line here. It's a linear line. Then you can generate a function. If let's say you can let's say this is when x, so this is x, this is y. So when x less than maybe 0.3.1, so your y is some function. Okay, if x is less than 3.1, you have some function here. Okay, then you should have another graph here. So this is a red color. Okay, if the x is less than, let's say 2.9, so your y is equal to 0. Okay, and then if the x is in between the 2.9 to let's say 5, you should have some functions. Okay, so you have a 5 to 7.2, let's say you have some functions. So let's say x is more than 7.2 and your y is equal to 0. Okay, you can generate the functions from the graph here. So I just lovely generate the graph or generate the functions from the graph. Okay, then last one same goes to the high class. Then you can generate another class here. So if the x less than, let's say 6, so your y is equal to 0. So if x is between 6 to let's say 8.7, you still have some functions. And if your x is more than 8.7, let's say, then y is always equal to 1. You should have this graph. Okay, so this blue color here is refer to this line. It's a function line. So these 4 red color functions is referred to this graph, and the black color here, these functions, is referred to this graph. Okay, so I repeat again. So how to generate the fuzzy sets? You have to generate this table first. Okay, so you have to ask yourself to what extent you agree that this value or measurement belong to these classes. You quantify it, and then you generate a so-called membership graph. From the membership graph, you can generate the membership functions. Okay.
Is it when I present my exam, I have to go through 3 tables or just 1 table, but using different colors? Or just a graph?
Just a graph.
Graph.
Yeah. So I use different colors because you can easily see that we have 3 different classes: low, medium, and high. Okay? Is that clear? So this is the fuzzy set of the input, only for input. Okay, you have to repeat for the output as well. Okay, so you would like to use the weight, which is the heaviness of the cloth, to decide the amount of water to use to wash your clothes. So same goes to the output. You have amount of water. I said this is a liter. Okay, so you have three different classes as well. So you have a low, medium, and high. Okay, so let's say amount of water I will set 0.1, 2, 4, 6, 8, 10, 12, 14, 60. Maximum I have 60 until 60. Okay, then same, we have to repeat the same process. To what extent you agree that 0.1 belong to low? Okay, so you believe, right, 0.1 is belong to low. So you still have a very high value here. Okay, so you have a repeat. You have to repeat this value. Okay, so I'm not going to write the value. So I think the value is roughly same like the previous table one. So you have the degree of membership for each of the classes for the output. Then you have to generate the same graph for the output here. So this is your degree of membership. So this x value is the amount of water. Okay, or water level, liter. Okay, so you draw the graph. So eventually, I believe you will still obtain the same graph like this. For example, so the graph here, it depends on your data set. It depends on your so-called measurements. Okay, sometimes you could have a Gaussian graph. Sometimes you could have a trapezium graph. It's not always the same. You could have this different type of graph. Okay, so you should have a sigmoid graph or exponential graph, or you should have this trapezium graph, or you should have a Gaussian graph. It depends on your data set. Okay, so yeah, so let me label this first. Assume that I have, this is 1, 2, 3, 4, 5, 6, 7, 8, 9. So always remember the degree of membership is between 0 to 1. Okay, so you build this table. So this is very important. First step, you have to build the fuzzy set for the input and also the output. Okay. So in this example, I will just use the weight to control the amount of water. You could have more than one output. For example, spinning speed, spinning time, washing times, and extra. Okay. So I'm going to show you how do we solve the uncertainty. Okay, so this is overall, this is the so-called Mandami inference mechanism here. So before we start to infer, the second step you have to do after you develop the fuzzy set is you have to develop the fuzzy rules. So this is step 1. You have to develop the so-called fuzzy set for input and the output. So step 2, you have to develop the fuzzy rules. So what is fuzzy rules? It's just a normal rules. If, let's say, the weight is low, let's say, okay, then the water level is low. Make sure that it's logic, right? If the weight is low, means that the amount of cloth is low, then the amount of water to wash the cloth is also low, right? Makes sense. Okay? Okay, you can set also if the weight is medium, then the water level is medium. Okay, you can also set if the weight is high, then the water level is high. So you have 3 different fuzzy rules. Okay, so what is the difference between fuzzy rule and the Cribbs rule? The fuzzy rules, you cannot have a value here. If you still remember back to the torque, the measurement of the torus here, so we come up with the rules where if the torque is more than 180, then it is torque. Correct? But in this case, no. In this case, we don't have any values. Everything is linguistic variables. It's just the descriptions. Like, for example, if the weight is low, then the water level is low. There's no value here. Okay? Okay. Wearing mask, very difficult to talk. Okay. So that's after you set the fuzzy rules. Now, let's see how do we perform the inference. Okay, so look at this inference system, which is called Mandami. Okay, assuming that now, okay, so you take the cloth, you put inside the washing machine. Okay, you throw all your cloth inside the washing machine. So inside the washing machine, we have to measure the heaviness. Okay, so inside here we have a sensor, kind of sensor. So let's say we measure is about 5 kg. Okay, it's about 5 kg. Okay, we put all the clothes inside the washing machine. So there is a sensor. So the sensor will measure, oh, it's 5 kg. So this 5 kg is a system input. Okay, it's a value. So this 5 kg here will go through a first process called falsification. So what is falsification? Falsification is a process to convert a numerical value into a linguistic value. So what is linguistic value? For example, low, medium, high. Okay, so we have a 5 kg here. Okay, we have a 5 kg. We have to go back to our input. We search where is the 5 kg, somewhere around here. Correct or not? Then we draw a line. We draw a line. Let's say I don't want to put 5 kg. Let's say I put 4.3. I change 4.3. Okay, so you go to the input, you search where is the 4.3, maybe somewhere around here. So then you can draw a line here, vertical line, until you hit the intersection point. Okay, and then you find the intersection point. So you hit this point here, then we try to find what is the value for the degree of membership. So maybe this one is somewhere around 0.8, which means that if you have 4.3 kg of cloth, we have to falsify this into 0.8 medium. This is okay. So means that we have a numerical value, we convert into some linguistic value, which is you have 4.3 kg of cloth, you draw a vertical line, you hit a point, so you hit this medium graph. Okay, and then you draw a horizontal line here, it shows 0.8 degree of membership. It means that if you have 4.3 kg of cloth, it means you have 0.8 median of cloth. We convert the numerical value into a linguistic variable. Okay, so it's called falsification process. We falsify the numerical values. Okay, so after that, you have this 0.8 mediums. We have to go to the fuzzy rules. We check which rule should fire. If weight is low, do we have low here? No, right? So this first rule is not going to fire. How about this? If weight is high, do we have high? No, right? So this one is not going to fire. Okay, you have median. So the weight is median, yes. We are going to fire this. Okay, check with this. So you're good. You got this median from the graph, right? You hit the intersection point. So it means that if you have 4.3 kg of cloth, it is actually, if you convert into the fuzzy side, it's actually referred to 0.8 medium. Okay, so among all the rules, which one should fire? Medium, no? Okay. So it means that if the weight is 0.8 medium, we are going to, the water level is also 0.8 medium. Okay, if you have 0.8 medium, then you will generate 0.8 medium of water levels. You have to use 0.8 medium of so-called medium level of water towards the 0.8 weight of the cloth. Okay, so 0.8. So we have to go back to the fuzzy set or the membership graph at the output here. So find where is the 0.8. You have a 0.8 because you have a 0.8 input. That's why you will generate 0.8 output as well. So this 0.8, you draw a vertical line, a horizontal line. Okay, since you fire the second rule, if the weight is medium, then the water level is medium, then you just focus at this medium graph. Medium membership graph. Focus at this. So this one you can ignore because we are not going to fire these two membership graph. Okay, so we have this horizontal graph, then you get area under the curve. You get area under the curve for the median graph. Okay, so you have this graph here. We have to convert this area under the curve back to some numerical value. Get back some value here. So how to get back some value? There are several techniques. The one of the famous techniques called center of gravity. You have to find the center of gravity for this shape. What is center of gravity? Have you learned physics?
Yes.
Yes. What is center of gravity?
9.8.
You're not taking physics in your Form 5, Form 4? No. Anyone taking physics?
No.
Sanjay.
No.
Center of gravity is a concept where it's a point where you are going to balance one object. Okay, so let's say you have one bar like this. So which is the point where you want to balance? Definitely this point, right? So that these two are actually balanced. If let's say you have an object like this, you have an object like this. Okay, what is the center of gravity? It's not here. If you put here, you probably, this one is heavy, right? So this one will fall down. So probably the center of gravity is somewhere around here. It's the point that you want to measure, you want to balance two different sides. Okay, so I'm not going to show you, teach you how to find the center of gravity. If you are interested, then you can find out more information about how to convert or how to get the center of gravity for this area under the curve. So it's probably using the integration. Okay, center of gravity is equal to x. You have a fx or dx divided by integration of dx. So if you learn physics, then you know what is this equation. If you're not learning, it's okay. You forget about this. Forget about this. So you can use this equation to find the center of gravity. You have to convert this so-called area under the curve back to a value here. If you convert back to a value, I assume that you will get 5 here. You will get, let's say, 5 liter. So what does it mean? It means that if, let's say, you have 4.3 kg of cloth, you require 5 liter of water to wash the cloth. That's the meaning. Okay? Remember, in the traditional ones, whenever you put 1 piece or 2 pieces or 3 pieces, the amount of water levels is always set. It's always preset, which is equal to 15 liter, let's say. So by using fuzzy logic, we are able to reduce 15 liter of water back to only 5 liter of water. Reduce the amount of water. Okay, we find the optimal amount of water to wash 4.8 kg of cloth. Okay, but you don't hate, but you don't really understand. Okay, so that is the general ideas lah. What we are going to find what is the optimal output to solve or to let's say to solve or to wash the 4.2 kg of crops. Assume, let's say now, okay, you put inside, you get 2.8 kg. We have another case 2.8 kg, second case. Okay, if I have 2.8 kg of cloth, so how much water should we use to wash the cloth? So let me clean the board first. Okay, 2.8. Let's say this is 2.8. Okay. So let's say you have 2.8 kg of cloth. So same, go back to the fuzzy set for your input. Where is the 2.8? Somewhere around here. Correct or not? 2.8 kg. So you draw a vertical line. You hit the first point. Okay, so which is, let's say, 0.1 medium. At the same time, you further extend this vertical line, you have another point here. So this point is actually low membership graph. Let's say this is 0.4 medium. So which means that if you put 2.8 kg of cloth, you will obtain two output, which is 0.4 medium and 0.1 low. Okay, so I repeat again. You have a 2.8 kg of cloth. So if you draw a vertical line, you will hit 2 points here, 1 point and 2 points. So the first point you hit is the medium membership graph. The second point is the low membership graph. Okay. So now you have these two values. Next step, you go to the fuzzy rules. You go to the fuzzy rules. So which rules should you find? Which one? Is this one correct? Do we have a low here? Do we have a low? Yes, we have a low here. So we have a low here. So this one fire. Okay, the weight is medium. Do we have a medium here? Yes, we have a medium. So we fire the rules number 2. Do we have a high in our output here? No. So we are going to fire rules number 3. Okay. Until this is okay. So which means that you have a 2.8 kg of cloth is going to have 0.4 medium and 0.1 low. So it means that you have 0.4 medians of water level and also 0.1 low of water level. So this is the output. By having this input, it will generate this output. Then you just draw a horizontal line, 0.1 low. So this is 0.1. So this is area under the curve. And you have another 0.4 medium, somewhere around here. So you draw a horizontal line. So this is 0.4 medium. Okay, and you combine these two graphs here, you will obtain something like this. Okay, so you have this graph, then you use this center of gravity to find the center point. So I assume that this value is about 5.2, somewhere around here, let's say. So we assume that if next time you have 2.8 kg of cloth, you are required to have this 5.2 liter of water to wash the cloth. Okay, so that is the ideas. Yes. Okay. Yeah, you're right. So this one is medium, 0.1 medium and 0.4 low. Okay, there's a mistake here. So 0.4 low. This is 0.1 medium. Then we have different graph. 0.1 medium. 0.1 medium is here, and 0.4 low you have here. Okay, terbalik. You should have this graph. Huh? you're not required to draw a graph for this question. Actually, if you look back at the partial questions, you don't really need to develop the fuzzy set. You don't really need to. I think the most questions in these chapters will be to come up with the applications. What are the applications that use fuzzy logics? Okay, or develop the fuzzy rules. Develop the fuzzy rule for the application that you mentioned. We won't ask you to develop the fuzzy set. It will take a lot of time. Okay, so that is the overall ideas for Mandani inference mechanism. If you use Sugino, then it will be different techniques. Okay, but the overall idea is we are going to convert a numerical value, classify a numerical value to some linguistic value. From the linguistic value, convert it back to a numerical value. Okay. Okay. So any questions for this fuzzy logics? No. If no, then we should take a rest for 10 minutes. Then I will come back to tutorial 13. Are you coming for tomorrow tutorial? What your group lah? Yours is balance there. Okay. How about your group lah? No.
没有生气啊。
Inform me lah if you're not coming. And I no need to go to the class.
他明天是没有课，明天有课，
明天你要做红日的，
那就不要去啊。有去吗？
不懂，要做红日的。
Who is going to present later? Your group.
啊
And
有了。
And Witten,
啊，
reason. Who is reason?
还要。
where
Someone.
Yeah, for me.
Are you doing assignment?
Yeah, what time?
You use my class to do other assignment. Will you use other class to do my assignment?
真是
Then why you don't use my class to do my assignment and use the another class to do?
因为你要3班交了。没有时间啊，老师。没有时间。
晚上？
啊？啊？下个班有。我们 present 了吗？只是还叫我们做 improvement。
我不是我啊。
我签吗？要啊。
我签字。
抄定位啊？
抄
抄定位。
Your lecture?
汪天籁。 我们平平，你们上面啊。
Okay, your group at least you have 1, 2, 3, 4, 5, 6, 7, 8. This one is 1, 2, 3, 4, 5.
拿不到。
No, not full attendance. Who else? Wei Han, Wei what? Wei Han. Wei Han last week present in U1 and Xiao Yan. No, Xiao Yan. Who else? Okay. Oh, Shanghai.
你们也是可以的。
Shanghai.
啊？哦，你们只做 back end 啊？
两个都做好。
做好了吗？
那两个 report 里面有没有？那 report 那个 report 里面。
No, last time management says not report. Well, sometimes we make some joke or whatever, then we switch there. For interview is okay.
今晚又是不眠的一路。
生气啊，生气啊，不然我死了。
我最近9点就睡了，你是要刚刚早上起身吗？操！
还是需要这样子。真的。
Come. Only presenter. FIB. Miss Azul. She's very busy lah, don't catch her.
有啦，要不要去哦？我听不去，我们可以不要去。去什么哪里？不要去。去哪里？
我去问访问来。
我问 assignment 呢？哦，你们不要来打架。
你是也想问，但是我没有东西。
没有去。
One is the presentation. Formal methods.
Present already.
Over already lah. So some other group they are not yet present.
都 haven't submit 啊。
assignment.
我们拜三角。
Oh. So it's different date.
Present first and then submit later.
Because you only present part of
Individual present 嘛。
Individual presentation.
因为自己做模，跟别人。
而且你 present 一个 part 罢了，你不是 present 嘛？所以你不用做完。
This also okay one. Very nice. He's my AD lah last time.
应该有吧？
Very good.
要去不要去？
Huh? Are you taking formal methods? Is it okay, Miss Azul? Very good one, right? She was very stressed. Miss Azul. She's AD ma. A lot of documentation do one. Very busy. AD is an associate dean. How about you? Finish your assignment? Submission? So waiting for presentation. No worries. So you are free lah. The rest of the skills have a lot. Then you can start. Then you apply. Okay, so welcome back. So we still have 42 minutes. We just go through the tutorials. Okay. If you look at the first questions, following is showing a sample of Cripps rules. As what I mentioned is Cripps rule is you classify if the temperature is 37.5 degrees Celsius, then you categorize you have fever or not to have fever. True or false? Yes or no? Okay, so this is a typical Boolean logic. So explain the difference Cripps rule and the fuzzy rules. So in this question you can say for these questions the output is either true or false. But meanwhile, fuzzy rules that you assign a degree of membership to so-called a measurement instead of to assign true or false to a measurement. You assign some degree of membership, just like the tall. You cannot just say, oh, if you are more than 180, then you are tall or not tall. So in this case, you should classify as okay, you're somehow tall, you're quite tall, you're not really tall. Right? Okay, so suggest how do you convert? So how do you convert this in back to the fuzzy rules? Okay, so always remember the rule of thumb for the so-called the fuzzy rules. We have a if temperature is more than 37.5, then fever is true. So this is a Cripps rule, so you have to convert into fuzzy rules. You can say if temperature is low, if temperature is high, then the fever is severe. Okay, so that is the solution. So this is the Cripps logic. So this is fuzzy logic. So always remember in the fuzzy logic, this high severe must be linguistic value. Linguistic. Okay, so what is linguistic? Low, medium, high, some adjective. Okay, you can't have a value or you can't have a so-called like true or false. You want me to? Can. Okay, so the first question showing these rules is actually a Cripps rule. So what is the properties of the Cripps rules? Where you will see that we set a threshold value, and to classify whether you are fever or not fever, right? You are yes or no, true or false. So so how to convert? Then you just change a value to some linguistic value. For example, if the temperature is medium, then the fever is severe, or the fever is medium, or the fever is light. Okay, so this two here is no longer true or false, but you have some description here: low, medium, high. Okay, design appropriate fuzzy set to represent input and output variable respectively. So for the question C, you should design something like this. For the question C, this is the answer. So I'm not going to start from the scratch. I will just lovely draw a graph so you can say the temperature. You should have basically three classes: low, medium, and high. Let's say fever. Okay, fever you should have light, maybe medium, and severe. Okay, so you should have a graph, degree of membership 0 to 1. So this should be your temperature, degree Celsius. Okay, so I just already draw lah. You should have maybe you can have a Gaussian graph, something like this. So this is low, medium, and high. Okay, and for the fever, maybe you can say fever level. Okay, so this is 1, 2, 3, 4, 5. Okay, so this is degree of membership. So assuming that you have the almost same graph. So this is light, medium, and severe. Okay, so from the graph, then you have to come up with the functions as I mentioned. So you should come up with the functions. Okay, so if x equal to what, then you should have x. Okay, so that is the rough answer for C. To have a more accurate answer, then you should have to refer back to this one. Okay. Okay, so maybe you're confused. What is this? Okay, so first you have to define your input and output. What is your input? Temperature. What is your output? You have to define the fever. So it based on the temperatures, then we conclude. Okay, what is your fever level? Is it severe? Is it medium? Or is it light? Okay, and we can further extend the classes under this measurement. Okay, temperature we should have low, medium, high. If you have more, then you can design more than 3. So this I just defined 3. So fever you can also define light, medium, and severe. So now you have 3 different classes to describe the fever. You have a severe fever, you have a medium fever, I have a light fever. Okay, so once you have this, identify the classes for each of these measurements, then you should start to measure. Okay, then you ask yourself, if let's say the temperature is 27 degrees Celsius, so 27 degrees Celsius belong to low, so 27 degrees Celsius belong to medium, or 27 degrees Celsius belong to high. Okay, so you come up with this table. So you have this table, and you can draw the graph. From the graph, you can generate the functions. Okay? Agak-agak lah. Matter how sure you are, how sure that you really understand this. Certainty factors 0 to 1. 0.2. Brandon? What is this stop? 0.5. You? 0.6, okay. Good. You don't really need to design for this.
Not so.
Okay, so that's why I say past year question is very quite important. If you look at past year question, we don't really ask you to design the fuzzy set, because to design like this, you probably have to spend a lot of time. Here, I just largely draw or give a value, but in fact, you have to do a very thorough research to find out what's the value for the particular classes. You cannot simply assign 0.2, 0.1. No, you have to study and you have to do some research and then get the value for each of the classes. Okay. So for question 2, illustrate the general structure of fuzzy inference system and explain each of the components. You can get this from here. I think the slide. You can get the answer from here. But unfortunately, I think I have removed the explanations. Okay, but you can get the explanations from the Google. What is the user system input I mentioned? So this is the system input. So you have to fuzzify it and do a mapping based on the rules, and then we finally defuzify it. Okay, so that is the answer for question 2. Okay, so question 3. Assuming that you are designing an automated conditioning system using fuzzy logic, suggest an uncertainty in the above scenario with explanations. Yeah, you can say the temperature temperatures. We cannot say that, okay, if the room temperature is 27 degrees Celsius, it is not cold. Above 27 degrees Celsius is cold, something like this, no. Okay, you shouldn't have one cup set a threshold value and says, or if you have a temperature less than this is belong to cold, and you have more than this belong to not cold. Okay, for question 3b here, generate 2 input and 2 output membership functions. They are able to model the A conditional system. Can you give me 2 input that you think is very important that affect how you control the so-called the temperature of the icon? What the factor?
The temperature of the room.
Okay, so room temperature, very good. And
Ventilation and the meter.
weather. Weather. How do you quantify the weather?
Ventilation.
How do you measure raining?
已经超过5毛了，太快了。
Yeah, but how do you quantify the raining? How do you know that it's raining? How do you tell the machine that, oh, this is raining, this is not raining? You should have some data. Like for example, temperature. Temperature you can measure using thermometer. How do you measure raining?
Humidity.
Okay, humidity. Maybe you can say humidity. Very good. So humidity. So if let's say raining, we know that if raining, the humidity is very high, right? Right. Yeah. So humidity is something that you can measure. Okay. Yeah. So this is the input. So what is the output? What are the so-called measurement that you would like to control? Okay. What are the output? Temperature. Okay.
The fan.
Okay, so maybe temperature. Yeah, the fan speed. Okay. Shopping.
On off.
On off. Okay. On off. On off. On off can also lah, but it's not really applicable for fuzzy logic. You could try. Fan speed. Temperature. I think good enough lah because you have two. You just need to design these two. It's good enough. Means that you have to use the room temperature and the humidity to control the temperature of the aircon and as well as the fan speed. Okay. Suggest yes. So suggest 2 fuzzy rules that associate in the fuzzy membership functions generated in the 3b. So for B, it's not yet complete. You have to generate the functions like this. Okay, you have to develop for each of these so-called factors. You have to develop. So it means that you have 4 different graphs. You should have 4 different graphs for each of these factors. Okay. So question B, question C. Suggest 2 fuzzy rules. Then you can say if the let's say room temperature is hot, is warm, then the fan speed is hot. Makes sense, right? If the room temperature is warm, it means it's quite hot, then you're going to increase the fan speed. Okay, you can also say if the humidity is wet, let's say it means that quite cold, then the temperatures is medium. It also makes sense, right? The humidity is quite wet, it means that it's not really hot, so you're going to set the temperature to mediums. It's not too cold, it's not too hot. Okay, so that is question C, the fuzzy rules. Okay, so for question 4, you probably just need to draw the graph because the function is already given. Is the temperature is more than 21. Then you just need to draw a graph like this. If the temperature is more than 21 degrees Celsius, then you just have some function. Okay, so I just show you one example for the first case, low.
你只是没有
Okay,
听
if
好，没听好
so
你。
this is for low membership graph. If temperature x is more than 21 degrees Celsius, then it's 0. If you have between 19 to 21, you should have some functions. If the temperature is less than 19, it's all 1. So you should have something like this. So that is the graph for low. Then you have to repeat for medium and high. Okay, you just based on the value and just draw a graph. The function here, this tmx, so it just function. It's just any line. You can draw any shapes. It's just a function. No question mark. Okay. Alright, so for the medium, same now. So if the temperature is less than 20, more than 28, so you have some graph here. So propose one fuzzy rules, then you can say that if the temperature is low, then okay. I think this is one of the very old past year questions. It's back to 2019. It's not set by me, it's set by some other lectures. Okay? Alright, so yeah, that's it for this topic. Any questions? No questions? Thank you.
So there won't be any drawing for this.
Yeah, like this, then you should have. If let's say you're required to draw, then we will provide you the kind of functions. A function like graph, like these functions, then you have to roughly draw the graph.
We will do that during tutorial.
Pardon?
Will we be doing this during tutorial?
So this is tutorial questions. So we won't have a tutorial 13 because we are already in week 12. And this week, next week we will cover tutorial 12. So then today that's why I will cover tutorial 13.
So week 13 will be doing.
No, next week we will doing tutorial 12. So we don't have time to do tutorial 13, so that's I'll take these hours to do tutorial 13.
How do we do it?
And then, so I'll show you one example already. So you want to draw a medium? Yes, can. Okay, so let's say I draw the mediums. If temperature is less than 20 or more than 28, less than 20 or more than 28, so you should be 0. If temperature is in between 20 to 23, okay. So less than 20 is all 0. It's more than 28 is 0. So it's between 20 to 23, let's say 20 to 23. You have a functions. Okay, 25 to 28, you have another functions. Maybe something like this. Okay. So if one.
看得出来。
Okay, so last one high. If temperature more than 27 is 0, less than 27 is 0. Between 27 to 30, okay, then you should have this. So that's the graph for these functions. Okay, so when is your final?
26.
26.
My
I heard
birthday.
it's a very soon birthday, is it? Your birthday.
Oh, yeah. So,
Is it your birthday?
Yeah.
26. So is it your last paper?
有啊，
You want to go celebrate?
也是一起啊，一起海底捞。
So many people. 对吧？
老师还要坐后车厢啊，后车厢。
你给他一根绳子，然后绑在路边。
然后你牵着他走。
After week 14, I think next week start from next week I'll be a bit free lah. For this 3 weeks is not free.
我有送到 free 啊。这个 blockchain 啊，昨天晚上屌的。
So yeah, I think you have plenty of time to prepare for this subject. Yeah. So I hope not to see you again next semester. In the campus, around the campus is okay lah. You can see around the campus, but not to take the same course. As you can see, is it tough for this AI course? Last week you told me very simple. Today you told me different things. Last time you say, oh, I thought AI is very tough lah. What not calculation or
可以吗？是没有讲，没有讲很难。他们真的很多做那个不是，因为我其实接另外我但就在哈佛上，
I mean during the
class,
class, because AI is an application so I cannot come up with the coding questions. You have multiples, you have 1,000 ways to write an
我没有
application.
生气，我只是屌。
Even the expert system you can use, if you're not using if you can use on this. So cannot. So yeah. So make sure that you study lah. I believe it's okay lah based on your midterm, the performance. I believe.
所以如果 assignment 没有太低分就可以 A 啊。
So what do you mean? What are you trying to say?
No, nothing.
Okay, so yeah, I think I'm not going to teach any other subjects. I don't think we're going to meet in any other courses. Yeah, I only teach. I think last time I taught resource method, C++. Yeah, C++. Yeah, my students. AI. What else? NLP, Natural Language Processing. One is offered for RDS student. It's not offered to RSW. Okay, so I apologize if I say something wrong. I mean, I like to take you guys as a joke.
但是我生气。
Sometimes I take you. I always ask the Jackson or I also take a Brandon. Yeah, don't put inside your
It's okay lah. They are
Brandon.
jokes lah.
It's just a joking. I just make fun lah. So yeah, don't take it seriously.
然后你看有讲，有了这么讲错吗？
That's the answer for 3A.
说没有 column 的，你的 information 是要 store 在 column 里面。对呀。
像你，我觉得你是要自己 follow 啊。可以了。他们就这样的。我也是觉得很聊。就是这样。就是我的。
Okay, so let's see. Today we still have a quite number of students, 20 students. Next week I foresee 10%. 10.
Depends lah. If next week you say, oh, I give guideline, 100% they will record some more.
对啊，没有错啊。
Next week no recording.
反。
Oh,
no recording.
啊，谢谢。今天星期那个 login 的那个，都已经去这蓝椒出来，
Tell you the guideline.
就可以买榴莲了。
I forgot already.
完
I
全
don't want to sneeze on even who
完
have
耶，
Are you still recording?
哦耶。
Stop recording.
OK。